It's this one, right? And if, honestly, if this were the array, 3, 4, 5, 6, 7, it would be this one, right? Right now, the last element of the array, that is less than the one next to it, is, when it's in order, is always the second to last one. But we should write an algorithm to make sure of that. So the first thing I want to say is largest I, I'm going to assume it's 0. And then I'm going to loop through the entire array. And what I want to do is say, OK, if vals index I is less than vals I plus 1, then largest I equals I. And I can't go to the very end, right? So I want to find what is the largest. And you know what I really need to do? I want to start with this as -1. Because I want to start with an invalid index. Because if I don't find anything, that's going to be important. If we go back to this algorithm, if there is no such x, that means we finished. So what I wanted to add here is say, right here, after I do this loop, if largest I equals -1, no loop, console.log finished. No loop is a function in P5 that just stops this animation loop from going. Going. Okay, so we can see that here. I've kind of implemented, I've implemented step 1 of the algorithm. And let me just, in the code here, just add a link to this article that I'm using, just so I don't forget to do that later. Okay, now, find the largest y, or you might think sort of in this, I'm going to use j, because I'm used to using I and j as index values. Find the largest y such that the index x that I just found, that's the largest one, is less than y. So let's think about that, right? So let's say, I think I might need a diagram for this. Oh yeah, I have my, so let's say we have a bunch of numbers, 0, 1, 2, 5, 6, 8, 4, 3, right? Let's find that largest x, which I'm calling largest I, such that the value in the array, the index is less than the one after it, which would be here. So 0, 1, 2, 3, 4. So this is 4. Now, so what's the next step? Whoops. The next step is find the largest y such that P of x is less than P of y. Not of, P index x. So I now need to find whichever one in here is actually less than this number 6. And that's actually here, right? This one is the largest one that's less than the number 6. So, so if we come back to the algorithm and I implement that, what I want to do is, I need to go through, and I'm going to use j. I'm going to go through the array again, and I'm going to say largest j equals -1. So what I want to do is here, the largest y such that P of x is less than P of y, P index x. So if vals index j is less than vals index largest I, which was x, then largest j equals j. So now I have largest I and largest j. I have both of those. And I don't think I need length -1 here, because I can check all of them. We'll find out. Now, swap P index x and P index y. Now, you might have come to this video without watching the previous one I made on traveling salesperson, but in that video, I look at a quick little algorithm for swapping two elements of an array, and here's the function that does that, right? I have a function called swap. I receive an array. I receive an I and a j. I save the value that's at A index I. I put the value that's at j in I, and I put the value that was at I in j. So now all I need to do is say swap largest I, largest j, right? And then reverse. Oh boy. So this is kind of a funny thing, but what I also now need to do is reverse everything that's between x plus 1 to n. Now, how do I do that? This is going to be a little bit goofy. I'm back from thinking about and talking with the chat about how to do this last step, reverse. So, but first, let's see. We did steps 2 and steps 3. Let me at least add some. This is step 2, and this is now step 3. And what I want to do for step 4, and let me write this out, is reverse from x, largest I plus 1 to the end, right? So what I want to do is reverse everything that's from largest I plus 1 to the end of the array. Okay, so one thing that I could do, I think a way that I could do this, thank you to the chat again, is I could say, I'm just going to call this end array, and I'm going to say vals.splice. Now, if you remember, I don't know what you remember this from, but if I go back to the my array documentation page, I'm going to look at splice, not slice, splice. What splice does is it takes a start index and then an amount of things you want to delete out of the array. But not only am I deleting them out of the array, I'm actually getting them as a separate array. So what I can actually do is say vals.splice from largest I, and then how many things do I want? I want, I think that the length is the array's length minus largest I. Is that right? Like if the array has 5 things in it, and my largest I is that's 0, 1, 2, 3, 4 is at 2, 5 minus index 2, minus 1, right? Vals dot length minus largest I minus 1, I believe is right. That's the length that I want to splice out. Let's confirm that. Let's debug this to be sure. 5, 6, 7, 8, 9. And what I want to do is I want to say a.splice. What happens, by the way, if I just give it the index? Like 2. So 2 should be 0, 1, 2, 5, 6 at 7. So I don't even need that last argument. Splice will do it for me. I don't need to calculate the length. Brilliant. Then I could say end array dot reverse. Now, does that actually change the array itself? A dot reverse. Whoa. Oh, A is that. Start over. Let's work this out. A is this array. Now, B is A dot splice 2. So now I have that as B. Maybe I need to make this bigger so you can see this. Now I want to try to reverse that. B dot reverse. But what is the B? It does actually reverse the array itself, not just create a new array that's returned back. So now all I need to do is say end array reverse. And then what I can do is say vals.append. I can just put it back. So what I did is I took the end of the array off, I reversed it, and then I put the end of the array back on, which is essentially doing exactly this piece of the algorithm. Reverse x plus 1. And did I add the plus 1 in there? I think I did. Plus 1. Okay, so I need to add that plus 1 in there. So this is done. I've done step 1, step 2, step 3, and step 4. Now what we should be able to do is look at those values and, and I should be able to run this again and sort of see what happens. Whoops. Vals.append is not a function. Hey, append is not an array. Oh, push must be push. There's no append function. Must be push. You must be allowed to push a full array, right? The elements to add to the end of the array, and you probably can push another array, right? I'm pretty sure you can. So let's try push and see if this works. And okay, this is too many things for me to see. Let's just do it with, let's run a quick little test here. And, oh, no. So how do I, concat? Maybe it's concat. Concat, because you can see what it did is actually just push the full array on there, which is not what I want to do. So let's go back and fix that. It would be nice if I knew what I was doing, wouldn't it? I guess you're seeing the process of how things are figured out by people who don't know what they're doing. Nope. Vals.concat. Let's look at concat. We're getting close. Concat. The concat method returns a new array. So I've got to set it back equal to itself. There's probably some sort of slightly more efficient way of doing this, but this will do just fine for us right now. There we go. Up. All right, so I'm getting something, but I'm missing something. So I have got to, I could use push.apply, but I'm trying to, so there's some fancy JavaScript ways I could do this, but I'm gonna try to kind of get around those ways. So something is going wrong here. So what I want to do is I actually want to take this, I want to actually just say no loop. And I want to be able to look at this running one at a time. So a way that I can in P5, by the way, is run each draw loop one at a time. One, as I can just say redraw. I thought I could at least. Oh, do I have no loop in here? Let's take that out. Do I have console.log? Maybe I took out the console.log. Whoops. Console.log vals. Yeah. Okay, so I'm getting the same array each time, and maybe the call to swap is incorrect, as someone in the chat is saying. So let me look this up. I'm now in a debugging portion, which maybe I'll edit. Maybe this should get edited out, but I guess it's staying in. Swap. So let's look and see what we're getting, if we're getting values that make sense. So the first thing I want to look at is largest I. And then I want to look at largest j, which is probably, I'm guessing I did something wrong there. And then I want to look, so let's just look at that for a second. So the largest I is 1, which makes sense. That's the largest index where it is less than 2. Now the largest j is, if we look at the algorithm, is the largest j such that, I have my code is wrong. Look at this. This should be largest I is less than j. If we look at that algorithm again, that makes total sense, that I'm looking for the element of the array furthest along that's actually greater than the one that I just found. So that should fix things up here. And then if I say redraw, okay, so that's a little bit better. I've made an improvement here that I'm finding. Let me refresh this. That the largest is 1, and then the largest j, which is 2, which is greater than what I just found, is the last element. That's correct. And I've got a terrible error here. Bad. Hello, welcome.